Hello everyone, my name is People Huang. In this video, I will answer two questions about my regression model for the medical insurance charges dataset. So the first question is, what did I do to improve the performance? First, I built a clean workflow using machine learning pipeline. This is important because it applies the same processing steps to both the training data and the test data, so the results are more reliable. Then I tried several regression models and compared them using five-fold cross-validation with MSE as the main metric in my benchmark results. The best cross-validation performance came from gradient boosting. Gradient boosting is CVMC with what this number, and the CVRMC is 4,592. Other models like gradient boosting and random forest are slightly worse, with CVRMC around 4,834 to 4,837. After that, I also did hyperparameter tuning using randomized search for two strong tree-based models. Astro tree and histogram boosting the tree results for best Astro tree model was this, and the best hist gradient boosting CVMC is this number is lower than this because cross validation is also use the holdout validation set to compare them again. Without this set, we can see the number of the two models is also lower than this. So based on this holdout result, I select the extra tree as my final model because it has a lower validation MSE and seem to generalize better. And overall, my performance improvements come from trying multiple models using cross-validation, tuning hyperparameters, and choosing the final model based on validation performance. So the second question is, what did I do to assess and improve the model fit? To assess model fit, I mainly use the three tools: cross-validation, learning curve, and residual analyze. First, I use the bifold cross-validation to estimate generalization performance. This is more reliable than a single train test split. Second, I use the learning curve RMC to the training RMC is lower than the CB RMC, and there is a consistent gap. When the training size increases, both curves improve, but they do not meet. This suggests some overfitting, meaning the model fits the training data better than unseen data. However, the CRMC also improves as the training set where more data pools still have, and the model is not completely unstable. And third, I check the residual plots of the validation set. More residuals are close to zero, but there are some very large positive residuals, meaning the model sometimes underpredicts it in some cases. This is common in this dataset because one number of people with extremely high charges. And due to this, histogram shows a strong center near zero, but a long tail on the positive side. This tells me the error distribution is not perfectly symmetric, and outliers still affect the model. And also based on these fit checks, I try to reduce overfit for tuning complexities for parameters and also models using those CP put out validation to avoid the treatment model that's to do the evaluation. So, thank you for watching.